Hi everyone, welcome to the part 2 series of chapter 2 Units and Measurement of class 11 physics. Today's topics are measurement of length. In this, we will study measurement of length topic in two parts, that is measurement of large distance, measurement of smaller distance. Then we will see a new method, parallax method. Then we'll see some details of measurement of mass and measurement of time. So in this video, in total we have four topics. Now starting with the first topic, that is measurement of length. Now we are already familiar with small and big measurements. Now you started measuring when you were studying mensuration and construction in geometry. You started measurements in mathematics geometry portion. Till now we are using the centimeter scale or meter scale for doing small and big measurements. Now simple scale that we are using, we can measure the least distance, that is 1 millimeter. Now next time when you have scale in your hand, you just see uh, we have 15 centimeters. The big lines show the centimeters, and in between 2 centimeters you can see 10 different small divisions. So those small divisions are nothing but they are the measure of 1 millimeters, right? Now millimeter still is not a standard unit, so the same 1 millimeter can be written as zero point 0.1 centimeter. The same can be written as 0.001 meter. 0.001 meter is nothing but 10 raised to minus 3 meter. Now, in physics, we will be increasing our scope of measurements. So, what we'll do, we'll need some different specific instruments to increase the accuracy. Now, in 11th standard, when you will do practicals, you will come across few special instruments which can measure more accurate, more smaller scale as compared to our simple scale. So few names we have here in our screen, that is first of all vernier calipers. Increasing the decimal, you see with the help of vernier calipers we can measure 0.0001 meter, that is 10 raised to minus 4 meter. So we became little bit precise with technology and physics. Again, if you go further, instruments like screw gauge and spherometer, that again we are going to use this in practicals, they can measure up to the accuracy of 10 raised to minus 5 meter. So that is how physics is helpful. You see, we are with physical, with the instruments that are derived, invented in physics, we are able to be more accurate. Now to measure astronomical distances, we need different methods. We cannot have any instrument to measure astronomical distances, right? So we'll go for a specific method called parallax method. Now, why this method is known as parallax method, that also you have to understand. Not going into much detail, let me tell you what parallax means, right? So the meaning of parallax is the apparent shift in the position of any object when it is viewed from different places at a time, right? So let us do an experiment. Okay, you can see one red arrow on the screen. Now hold your one finger in front of this arrow, exactly in front of this arrow, and look at it from your left eye, right? So in that manner, close the right eye and see exactly straight. You hold the position, hold the finger exactly straight in front of this arrow. Okay, now don't move your finger, don't move your hand, just change the eye. That means close the left eye and now look the same finger from the right eye. So you can see that position of finger in front of arrow will be changed a little bit, right? That means the finger is same, the arrow is same, but the position is changing because you are seeing it from a different position. Clear? Our eyes are little bit at different positions. Clear? So this is known as parallax, shift in the position. Clear? Now how this method is helpful for us, that to measure large distance such as distance of a planet or a star from earth can be measured by this method. Clear? So instead of our eyes we will see that planet, suppose moon, right? So we will have to see moon from two different or distant places from the earth. Okay, now how it is possible, let us see. So this parallax method, uh, you can see earth and moon, right? And few diagrams are added, like you see two different places are there, namely A and B. So on the right hand side I have given the information. What are A and B in the figure? A and B are diametrically opposite points, right? Now let M be the moon. Clear? So what will be AB? AB will be the distance between two places of observation. We will take observation of moon from A to M, then we'll go to B point and from B to M. So twice we are measuring the distance. Clear? One from A and one from B. So AB will be the distance between the two places of observation, and AM or BM will be the distance of moon from the earth. Clear? And there will be an angle between AM and BM that will be known as parallax angle. Clear? Theta, that is shown in the figure. So this method is very simple. You see, only three things we have to take care. Two distant places, the difference or the distance between two places, and the angle. Clear? Remember, we are finding the distance of moon from the earth. Clear? So let us see how we get the distance from moon from the earth. So we will use a very small formula. That formula is shown: angle theta equals to arc upon radius. This is the only formula. Remember, angle equals to arc upon radius. Clear? Now, this theta equals to, what is the arc? In place of arc, we are writing distance between two places of observation. So here AB is the arc. Now, below it is radius. So that is distance of moon from earth. That is our AM or BM. Clear? So the formula becomes angle equals to arc upon radius, theta equals to distance of two places of observation upon distance of moon from the earth. Clear? So that is equal to AB upon AM. So what we are finding is AM. Clear? Distance of moon from the earth. Clear? It may be AM or it may be BM as well. So now you have to just take this AM on the left hand side and take that theta on the right hand side. Clear? So now we have a distance of moon from earth equals to AB upon theta. So we just need two values, that is, first of all AB. We might know the distance between this A and point B. Clear? So if we have AB and theta, we can get easily the distance of moon from earth. Now till now this is theoretical explanation. If in case we have some numericals, so we will have some numericals solution for this method so that you can understand it better. Clear? So just remember that we have a very small formula, angle equals to arc upon radius. So if you know any two, you can get the third one. Clear? Now, measurement of small distance. We cannot use scale, vernier caliper, micrometer, screw gauge or similar instrument for measurement of small distances. So we again have to use some specific instruments. Those specific instruments are microscopes, right? So there are variety of microscopes. Optical microscope, they can measure up to 4000 angstrom. Now below I have written what is the relation between angstrom and meter. 1 angstrom equals to 10 raised to minus 10 meter. Okay. So imagine how much small it will be. So optical microscope can measure up to 4000 angstrom. Still going into little bit more detail, electron microscope's resolution is 0.6 angstrom. Clear? So you see, we are using electron microscope to study the nuclear models, right? Model of atom and all. Then we have tunneling microscopy. STM and AFM are two type of tunneling microscope. I'll tell you the full form. STM is scanning tunneling microscope and AFM is atomic force microscope. So these two microscope again are used to measure very small distance, right? In physics, we are dealing with smallest of small to very large distances. So in physics, we have many different names of units, right? So it may be fermimeters, it may be angstrom, it may be AU. AU is the astronomical unit, and light year, parsec, etc. Just will tell you what is the definition of AU. It is the average distance of sun from the earth, right? And it is approximately 1.5 into 10 raised to 11 meter. Clear? Even light year has a definition, the distance traveled by light in 1 year, and parsec is the largest unit of distance till we use. Clear? So moving on to our next topic. Our next topic is measurement of mass. Now what is mass? It is the amount of matter in the substance, right? And what is weight? Term related to mass but not actually mass. We have been contradicting mass and weight and combining these two concepts in our daily life, right? But what is weight? Weight is the gravitational force acting on any substance. Clear? Now in reality, when someone asks what is your weight, you are telling that in kilogram, but you know that weight is never in kilogram, it is in Newton, right? Right? Gravitational force will not be in kilogram, it will always be in Newton. Clear? So this contradiction in daily life it is okay, but when we are studying physics we must take care that we use perfect name of units, symbol of units. Now mass remains constant because ultimately amount of matter will always be constant. We cannot destroy matter, we cannot create matter, right? But weight can change as it depends on the gravitational force. Clear? You move to a surface or a place where gravitational force is different, your weight will be different. Like we always say, weight of some object on earth and the same weight if you find on moon it will be 1 upon sixth time, right? So that is the difference, weight will change. In our normal daily life we use units of mass like kilogram and milligram, but we must know that in physics we deal with mass of atom till the mass of known universe. See the difference, mass of one atom and mass of whole universe we deal. Clear? So that is the range of mass that we study in the physics. We use units like AMU, atomic mass unit, that is 1.66 into 10 raised to minus 27 kilogram. You might have come across this unit when we talk about mass and mass of atom. We can relate that with chemistry as well. Clear? So you can find AMU in chemistry also. Now, large masses can be known by Newton's law of gravitation, and again, for small masses, we can use methods like mass spectrograph. Okay, right now we don't have any utility of these all mass spectrograph and all methods, so we won't study that in detail. Just remember the name. For measuring very small masses, we use a method like mass spectrograph. Clear? Now moving to the last topic of this video, that is measurement of time. Now in earlier times we use shadows of tall objects to measure the time. They were known as obelisks. Again after that we improved a little bit and made some clocks, but then again they were not accurate, like water clocks, sand clocks, sundials they were used, but they were not very accurate, right? So these days what we are using clocks and watches. Now whenever you see a big clock, you may find a small word quartz, right? Now quartz is very important word in measurement of time because you see you must always wonder how the second hand or the minute hand or the hour hand moves. Okay, most important, how the second hand moves, right? So second hand is connected with an element called quartz. When you connect the electric cell with that element, it vibrates. Okay, and that vibration only moves the hands of the clock. Clear? So basically, the vibrations are converted into motion in the clock. Right now, for accuracy, we depend on atomic clocks or cesium clocks. Specifically, remember the element cesium clocks. Right now, why cesium clock? I am telling that again. We use vibrations of cesium metal for measuring time. Now, how it might be related? You see the next point. In atomic clocks, how we are measuring 1 second? 1 second is the time needed for 91926317770 vibrations. Right? This much vibration, if it does, then the time taken is called 1 second. See how much accurate physics is, how much accurate and precise technology is. Here in India, we have atomic clocks at National Physical Laboratory, Delhi, and it helps us to measure or keep record of Indian Standard Time. Right? You measure, you open any news channel, and you may see the time, and in every news channel, it will show the same time. At every place, the time is uniform. Why? Because we are continuously measuring it with atomic clocks, right? The range of time which is studied in physics is from 10 raised to minus 24 second to 10 raised to 17 seconds, right? So this is the range of time in physics.